السلام عليكم. Cardiovascular system development, heart and fetal circulation. This is an introduction for the development of the primitive heart tube. Angioplastic cells in the cardiogenic area. The cardiogenic area ventral to the intraembryonic cellum and dorsal to the gut or yolk sac differentiate. This is the yolk sac or later on form the gut. This is the intraembryonic cellum. Intraembryonic cellum. This is upper view or superior view for the embryonic disc. This is the intraembryonic cellum, U-shaped intraembryonic cellum. The cranial part form the pericardium. The cranial part of the two vertical limb here form the two pleura, and the most caudal part here of the two limb form the single cavity forming the peritoneum. After cranial folding, this part become folded in between the two pleura here, ventral to the two and in between the two pleura here. So this is the cranial part of intraembryonic cellum that is represented here. This is the cranial part of intraembryonic cellum forming the pericardium. This is the heart tube formed from the angioplastic cells here. At first, the angioplastic cells differentiate into two endothelial heart tubes like this. So, angioplastic cells in the cardiogenic area, ventral to the intraembryonic cellum forming the pericardium, and dorsal to the yolk sac differentiate into two endothelial heart tube like this. Bilateral folding result in fusion of the two heart tubes, leaving two bifurcations, cranial bifurcation and caudal bifurcation. This is a bifurcation on the cranial end for exit of the blood, so-called arterial end, and this is for the entrance of the blood, so-called venous end. This is the single heart tube, leaving two bifurcation, caudal venous bifurcation and cranial arterial bifurcation. Then craniocaudal folding or cranial folding result in change in the position of the heart. Heart tube. Two lie here, two lie ventral to the foregut, connected to it by the dorsal mesocardium, and dorsal to the cranial part, of intra-embryonic cellum, represented, as we said, by the pericardium. Then later on, dilatation occur in the heart tube. To form, as we see, 5 sacs. To remember these letters: TB, vas. T represented by truncus arteriosus. B represented by bulbus cordis. V represented by the ventricle. A atrium. S sinus venosus. Then elongation and then folding occur for the heart tube. As a result of folding of the heart tube, the heart tube bulges ventrally into the pericardial cavity. Bulges ventrally into the pericardial cavity. Also, bulging of the heart tube occur from above downward. So the transverse sinus occur in between the two ends of the folded heart tube, between the arterial and venous end of the heart tube, the transverse sinus of pericardium. Then folding of the heart tube result in the atrium lies above the ventricle, connected together by atrioventricular canal, instead of the previous ventricle lies above the atrium. The heart tube gives rise to the endocardium, while the surrounding mesenchyme condenses to form myoepicardial mantle. This mantle differentiates into myocardium and visceral layer of pericardium, what is called epicardium. This is the most important point in the development of the heart. The previous was an introduction to know the definitive chamber of the heart and their feet. Here we focus on the feet of the chambers of the heart we previously said. The first is the sinus venosus. Feet of sinus venosus. As we see, sinus venosus is formed of two horns, left horn and right horn. Each horn receives three veins. Vitelline vein from the yolk sac, umbilical vein from the placenta, and common cardinal vein receiving the anterior and posterior cardinal veins for receiving the blood from the body wall of the embryo. Later on, as a result of shift of the blood from the left to the right side, the following changes occur. As we see, on the left side, as we said, there is a shift of blood from the left to the right side, so the left side is reduced in size, and on the other hand, the right side expands. Here is the feet of the sinus venosus on the left side. On the left side, the left vitelline vein disappears, as we see. The proximal part of the umbilical vein also disappears, as we see. The common cardinal vein here, the common cardinal vein becomes small, forming what is called oblique vein of left atrium. The common cardinal vein here becomes small to form the oblique vein of the left atrium. Then the left horn of sinus venosus, forms what is called the coronary sinus. This is the posterior view of the adult heart. This is the coronary sinus on the back of the heart. The coronary sinus, as we know, receives the venous drainage of the heart and open into the right atrium. Then the left horn of sinus venosus forms the coronary sinus that open into the right atrium here. This is the feet of the right sinus venosus, left side of the sinus venosus. Left side of sinus venosus, we repeat it again. Cardinal vein forms the oblique vein of left atrium, and vitelline vein disappear completely. Proximal part of umbilical vein disappear, and the horn here, left horn here, forms the coronary sinus. Then we come to the right side. The right horn of sinus venosus expand, as we see, expand and added to the cavity of the right atrium, forming its smooth part. Then the smooth part of the right atrium originate from the sinus venosus, the right horn of sinus venosus. Sinus venosus, sinus word begins with S and smooth part begin with S, so the sinus venosus forms the smooth part of right atrium. Which part of sinus venosus? The right horn of sinus venosus. Then we come to the vessels, the three vessels. The umbilical vein completely disappear, right umbilical vein completely disappear. Then the cardinal vein here forms the superior vena cava, while the inferior vena cava originate, its proximal part originate from the right vital line vein. To remember it also, the vena begin with V and vital line begin with V. So the right vital line vein for the proximal part of the inferior vena cava. This is the fate of sinus venosus. Then the fate of the atrioventricular canal, it's a small canal in between the atrium and the ventricle, is divided by atrioventricular septum into two halves or two canals by appears at first small cushion, ventral and dorsal cushion that communicate together, forming a complete septum, resulting in, as we said, into two canals. The right atrioventricular canal is added to the right atrium, while the left is added to the left atrium. Then development of the two atria. Development of the two atria will begin with the auricle. Auricle, just mention it. It appears as a bulge surrounding the bulbous cordis, right and left bulge from the atrium. This is the left auricle and this is the right auricle. And the bulbous cordis, as we know later on, forms the great blood vessels, aorta and pulmonary trunk here. So the auricle of the heart, the auricle of the atrial auricle or auricle of the heart here, left auricle and right auricle, surrounds the great arteries of the heart, originating from the bulbous cordis. Then come to the most important point, which is represented by the interatrial septum or atrial septum. As we see before, that the atrium at first is a common chamber, must be divided or should be divided into two chambers, right and left. The division occur through development of interatrial septum. So what is the sequence of the development of interatrial septum? As you know, that the atrium is above the ventricle. The atrium is above the ventricle that lies below it. So to remember, the atrial septum arises from the roof, from above, as the atrium lies above. So its septa arise from the roof or from above. It appears. So development of two septa. The first septum is called septum primum, primary septum or septum primum, and the second is called septum secundum or secondary septum. Then development of septum primum. The first septum is the septum primum or primary septum. It appears, as you see, as a sickle-shaped or semilunar here, sickle-shaped septum arising from the roof of the common atrial chamber. This is another view. This is the primary septum or septum primum. This another view. Then the septum goes downwards. So septum primum appears as a sickle-shaped septum, arising from the roof of the atrium, from the roof of the atrium. It descends downward towards the atrioventricular canal, the anterior and posterior edge, the anterior and posterior edge of the septum reach the atrioventricular canal, before the central part, So a temporary foramen here, is formed at the lower end of the septum, and this foramen is called ostium primum. With more growth of the septum downward, this ostium primum disappears. With more growth of the septum, the ostium primum closes, and at the same time, another foramen appears above, through breakdown of the upper part of the septum. The new foramen here is called secondary foramen, or secondary ostium, or ostium secundum. This is the ostium secundum, as it is the second foramen appears. This is the ostium primum, the first ostium. This is the ostium secundum, as it is the second ostium. The two foramina, ostium primum at first, then ostium secundum, are necessary for passage of blood from the right atrium to the left atrium during the fetal intrauterine fetal life. Then another septum is called septum secundum. Also sickle-shaped septum, also appear from the roof of the atrium, called septum secundum, or secondary septum, as it is the second septum to appear. So septum secundum appear as a sickle-shaped septum arising from the roof of the atrium. As you see, on the right side of the first septum, as we see. The aim of this septum to close the ostium secundum, but we need a foramen in between the two atria to pass the blood during the fetal circulation. So this septum stop when it reaches the edge of the first septum, leaving a foramen in between called foramen ovale. The gap between the lower edge of the septum secundum and the upper edge of septum primum here, this gap is called foramen ovale. That remains open till birth. It closes immediately after birth. Then, this is the development of atrial septum, or interatrial septum. Then embryological origin of the two atria. This is a comparison of the origin of the two atria. On the right side, it comes from the right half of the original atrial chamber, the right half of atrioventricular canal, and the smooth part of the right atrium, as we said, arises from the absorbed sinus venous. Absorbed right horn of sinus venous. As we said, this is S and this is S, to remember that it arises from sinus venous. On the left side, left atrium, arises from the left half of the original chamber. This is the right half, this is the left half. Left half of the atrioventricular chamber. This is the right half. Left atrium arises from the left half of the original atrial chamber, left half of atrioventricular canal, and the smooth part arises from absorption of the common pulmonary vein. This is a small vein here, receiving 4 pulmonary veins. So absorption of this vein into the wall of the left atrium forms the smooth part of the left atrium, and resulting in the 4 pulmonary veins open directly into the left atrium. Development of the 2 ventricles. The proximal part of the bulbous cordis, this is the ventricle, this is the bulbous cordis as we see in the diagram. The proximal part of the bulbous cordis, is added to the original chamber of the ventricle, or to form common bulboventricular chamber. This part is added to this chamber to form together the common bulboventricular chamber. This common bulboventricular chamber is divided by the interventricular septum or ventricular septum. Interventricular septum here, as to remember, the ventricle lies below the atrium, so its septum arises from below, from the floor. Atrium, as we said, its septum arises from the roof, while the ventricle, the septum originates from the floor, from below. So interventricular septum, a sickle-shaped septum develops from the floor of common bulboventricular chamber. This ascends upward to meet the atrioventricular septum and the bulbar septum. Here, the edge meets the atrioventricular septum on one side, and on the other side the bulbar septum, forming a temporary interventricular opening. Then this opening is closed by extension from the atrioventricular septum here, and extension from the bulbar septum here to close this temporary opening or interventricular opening here. So the ventricular septum or interventricular septum is formed from 2 sources. The lower part originating from the floor of the septum is the main part and is the fleshy part, while the upper part is membranous part, and it is the most common site for ventricular septal defect. This is thick part, while this is membranous part. The added portion of the bulbous cordis here, form the infundibulum of the right ventricle and aortic vestibule of the left ventricle. This is not an important point, but if you remember it, it is good. So, fate of bulbous cordis. Bulbous cordis, as we said, the proximal part called bulbous cordis proper. The proximal part, which is called bulbous cordis proper, is added or absorbed to the developing ventricles, as we said, forming the infundibulum of the right ventricle and aortic vestibule of the left ventricle. While the distal part, which is called truncus arteriosus, is divided, as we see, by a spiral septum. This septum is called the bulbar septum, or called aorticopulmonary septum. Aorticopulmonary septum, as the septum divides the bulbous cordis or distal part of the bulbous cordis into 2 arteries, as we said, aorta and pulmonary trunk. So the septum sometimes called aorticobulbar septum, aorticopulmonary septum, as it divides the bulbous cords into aorta and pulmonary trunk. This spiral-shaped septum results in different relation between the aorta and the pulmonary trunk. Near the ventricle, this is this part near the ventricle, this is the middle part, and this is the distal part. Near the ventricle, in the proximal part here, the septum is transverse, as we see, is transverse. So the aorta lies posterior. The aorta lies posterior to the pulmonary trunk anterior and the aorta posterior. Then we come to the middle part. The septum is antero-posterior, so the aorta lies on the right side and the pulmonary trunk on the left side. While in the distal part, this distal part is the reverse of the proximal part. Here the aorta is anterior and the pulmonary is posterior. Pulmonary trunk is posterior. As the septum descends downward toward the ventricle, it rotates in a clockwise direction. As you see, in the clockwise direction, so that the right part fuses with the posterior part of right interventricular septum, and its left end fuses with the anterior part. Therefore, the aorta opens into the left ventricle and the pulmonary trunk open into the right ventricle. Again, fate of bulbous cords. Fate of the bulbous cords, the proximal part called bulbous cords proper is added to or absorbed to the developing ventricles, while the distal part called truncus arteriosus is divided by spiral septum called bulbar or aorticopulmonary septum. As the septum is spiral in shape, we must remember this relation. So remember this figure and talk about this relation. The relation is evident in the anatomy as we see in the next slide. The part attached directly to the ventricle, as you know, the aorta open or emerges from the left ventricle. Aorta is left, and the pulmonary trunk is right. The second part, which is called proximal part to the ventricle, the aorta lies posterior to the pulmonary trunk, or pulmonary trunk in front of the aorta. The middle portion, the aorta is to the right, while the pulmonary trunk to the left. The distal portion, the aorta is anterior, pulmonary trunk is posterior. This part, distal part, is the reverse of the proximal part, and the middle part is the reverse of the part attached to the ventricle, directly attached to the ventricle. To remember this relation, as we said that the aorta is the artery of the left ventricle, so the aorta is the left, and the part attached to the ventricle. Pulmonary trunk is right as it emerges from the right ventricle, as you know. Also, the interventricular septum is oblique, so that the right ventricle is anterior to the aorta. You can remember it as when you enter the mosque, you enter with right foot. So the right is anterior here. The right is anterior. So pulmonary trunk right here is anterior in the next part immediately. So the pulmonary trunk is anterior and the aorta is posterior. Then reverse in these two parts. The middle part is the reverse of the first part, and the distal part is the reverse of the proximal part. You just mention the relation, not in need to how the symptom passes, but it should mention this anatomical relation to show your understanding to the spiral relation of the aorta and pulmonary trunk. This is a spiral relation of the aorta and the pulmonary trunk. As we see, this is interpretation to the previous slide of the bulbous cords. This is the pulmonary trunk and this is the aorta. In the part emerging from the ventricle, as we see, the aorta is left and the pulmonary trunk is right. So we come the proximal part here. Proximal part here, as we see, the pulmonary trunk is anterior to the aorta. The middle portion here, the pulmonary trunk is on the right of the aorta. Then the distal portion here, the aorta is anterior to the pulmonary trunk. Clinical correlation or congenital anomalies. Anomalies in position. Anomalies in position. The first is called dextrocardia or right-sided heart. Right-sided heart. The heart is directed to the right side, and its chambers are reversed. It results from reversal of the heart tube during development. This case is usually associated with situs inversus or reversed or inverted position of the fissura, of the internal fissura. So when we see dextrocardia, you may expect a left liver instead of its usual position in the right, and appendix on the left instead of the right. So this case is called situs inversus. All the fissura are reversed, including the heart. The second is ectopia cordis. Ectopia cordis. The term ectopia, like what you heard before about ectopic pregnancy. Pregnancy outside its normal site, inside the uterus. Also, ectopia cordis, cordis means heart. Ectopia cordis means heart outside its normal position inside the thoracic cage. In this case of ectopia cordis, the heart is exposed or bulged out on the anterior thoracic wall. It results from failure of development of the anterior thoracic wall, mainly the sternum. Here, the heart is normal, and we see it pulsating, but the defect is usually in the sternum or anterior thoracic wall. So the heart leaves its normal position inside the thoracic cage, and we found it outside the thoracic cage or on the anterior thoracic wall. Then, atrial septal defects. Atrial septal defects. Atrial septal defects, the first and the most common is patent foramen ovale. Patent foramen ovale. This is due to failure of closure of the foramen ovale. As we said, that the foramen ovale is patent during intrauterine fetal life, but just after birth, immediately it should be closed. It should be closed with the first breathing of the baby after birth. It is the commonest anomaly, as we said, of ASD, atrial septal defect. The foramen ovale is normally closed after birth, as we said, as the septum primum is forced out to fuse the septum secundum as a result of increased blood pressure in the left side of the heart or in the left atrium after establishment of pulmonary circulation. The blood pressure here in the left atrium increased as after establishment of the pulmonary circulation and the return of blood from the lung here, oxygenated blood. So the blood pressure here is increased than the right side, so it forces the upper end of the septum secundum to be enclosed with the lower edge of the septum perimum here, and the actual fusion of the two septa occur after the first year. In the first year, there is a functional closure, but not actual closure. Actual closure occurs later on after the first year due to close contact of the two edge. It closes by time. Actually closed by time to be as a one part. A small patent foramen ovale might not affect the person, so when we discovered it, it should not tell the person. Sometimes we do a small opening or minimal opening in between the two atria in some condition. But when it is large and affect the health of the person, it could result in shift of blood from when it is large. Blood is shifted from the left side, from the left atrium of higher pressure to the right atrium of lower pressure, then forming overload on the right side heart might result in right side heart failure and may be reflected on the lung, causing pulmonary congestion. So in this case, it must be surgically repaired, surgically closed the foramen ovale. But if it is small, causing no symptoms, no interference. The second anomaly is premature closure of the foramen ovale. Premature closure of the foramen ovale might lead. Premature means closure of the foramen ovale in the intrauterine fetal life before birth. If it occurs, it might lead to death of the fetus before birth. Complete absence of the septum. Complete absence of the septum. This is a rare condition caused by failure of development of both septum primum and septum secundum. So the heart is called monoatrial monoatrial biventricular, so formed from three chambers. This is a rare condition and incompatible with life. The another rare foramen is patent foramen of primum, or persistent foramen primum, and as on the same meaning, persistent or patent foramen secundum. Persistent or patent foramen secundum. Then we come to the ventricular septal defect. The first is interventricular foramen. As we said, it mostly occurs in the upper membranous part of the ventricular septum. The lower part is fleshy and thick, and so the ventricular foramen or interventricular foramen is mostly occur in the upper part of the septum or membranous part. Or the another is complete absence of the septum due to complete failure of development of the ventricular septum. Then we come to the bulbar septal defect. Bulbar septal defect. The first is fallot tetralogy. Fallot tetralogy. This is very important point. Fallot tetralogy. Fallot tetralogy caused by forward displacement of the bulbar septum. Forward displacement of the bulbar septum. So this word begin with F and fallot begin with F. So you remember the cause of phallotetralogy is forward displacement or anterior displacement of the bulbar septum. Anterior displacement here in the part attached to the ventricle. As you know that in the lower part the aorta is posterior to the pulmonary trunk, or pulmonary trunk is anterior to the aorta, the right anterior, as we said before. So when forward displacement occur, forward displacement of the bulbar septum occur, it results in stenosis of, as we see, stenosis of the pulmonary trunk, and on the other side, widening of the aorta. So as we see, the four congenital anomaly of phallotetralogy are correlated. The first, it is caused by forward displacement of the bulbar septum. Result in the defect is stenosis of the pulmonary trunk, overriding of the aorta, overriding of the aorta on both ventricle. This result, or this occur, or this is associated with ventricular septal defect. This is the third congenital anomaly. Also, the fourth congenital anomaly is hypertrophy of the right ventricle due to a trial of the right ventricle to push its blood through the stenosed pulmonary trunk. So the stenosed pulmonary trunk is associated with hypertrophy of the right ventricle, and overriding of the aorta is associated with ventricular septal defect. These are the four congenital anomaly of phallotetralogy. The another congenital anomaly is persistent bulbous cords, or persistent truncus arteriosus. Persistent truncus arteriosus. Persistent truncus arteriosus or persistent bulbous cords, this is due to failure of development of the bulbar septum, completely failed. So in this condition, one artery arises from the heart, overriding both ventricles. So there is no aorta or pulmonary trunk, but only one artery arising from both ventricles. This is called persistent bulbous cords or persistent truncus arteriosus. Another congenital anomaly is the transposition of the great arteries. Transposition of the great arteries, which, as you know, aorta and pulmonary trunk. Transposition of the great arteries. This is due to descent of the bulbar septum straight instead of the normal spiral manner. When the bulbar septum descends during development, instead of its rotation in a spiral manner or in a clockwise direction, it descends straight. So result in transposition of the great arteries. Transposition of the great arteries means the aorta arises from the right ventricle instead of the left, and also the pulmonary trunk arises from the left ventricle instead of the right ventricle. This is the transposition of the great arteries. Then we come to this premature closure of foramen ovale. This is related to the ventricular, the atrial septal defect. We mentioned them before. Venous system. The arterial system mainly the aortic arch is mentioned in the previous lecture of the pharyngeal arch artery. This is the venous system. The venous system, as we see, the development of the liver the development of the liver here divide the umbilical and vitelline vein into upper portion, lower portion, and middle portion. We begin with the vitelline vein. The vitelline vein, as we said, development of the liver here, divide the middle portion of the vitelline and the umbilical veins, forming the liver sinusoids. So the middle portion of the vitelline and umbilical vein forms the liver sinusoids. The cranial portion or upper portion of vitelline vein, on the left side it disappears, while on the right side, on the right side, as we said, form the part of the inferior vena cava. The right vitelline vein, the cranial part, form the part of the inferior vena cava. The caudal portion, the two veins, as we see, the two veins joined together by three anastomosis. This anastomosis surrounding the duodenum, as we see, or small intestine, forming what is called the portal vein. So the caudal portion of the two vitelline vein connected by three anastomosis, forming S-shaped portal vein. Then we come to the umbilical vein. The right umbilical vein disappear, the cranial and caudal portion. As we said, the middle portion of the vitelline vein share in the formation of liver blood sinusoids. The right umbilical vein caudally and cranially disappear. Cranially means towards the cranium, towards the skull, the upper part. Caudal means the lower, or towards the coccyx or caudal portion. These terms are firstly applied to the animals, but the animals, as you see, the head in the level of the tail, but in human, the head is upper and the coccyx, representing the rudimentary bone of the tail, is lower. So cranial is a term commonly applied to the structure toward the upper, while caudal toward the lower end of the body. So the right umbilical vein disappear. The left umbilical vein, the cranial part disappear, while the caudal part remains to carry the oxygenated blood from the placenta during fetal life and then obliterate later on. This is the development of the inferior vena cava, and it is not important point. We can pass it. The inferior vena cava arise from, as we see, anastomosis between the veins of the two sides, as we see. Arise from suprahepatic part, developed from the right vitelline vein, suprahepatic part from the right vitelline vein. Hepatic part form anastomosis between the right vitelline vein, from the right vitelline vein, and the right subcardinal vein. Subcardinal vein. This is the hepatic part. The lower part from the right vitelline, right subcardinal vein, Then the renal part opposite the two kidney by anastomosis between this part and this part. This part, as we said, the right subcardinal, and the lower part is the right supracardinal part. So the caudal portion, this is the renal portion, this is the post-renal portion, then this is the caudal portion, arise from anastomosis between the posterior cardinal vein to posterior cardinal vein, this and this, posterior cardinal vein. And this is anastomosis, this is a posterior cardinal vein, forming the caudal portion, which forming the two common iliac vein. Superior vena cava arises from, as we said before, arises from the right common cardinal vein, On the left side, it disappears as a shift. The shift, as we said, from the left to the right side. So the right forms the right superior vena cava. The right cardinal vein forms the superior vena cava, while on the left side disappear. So, development of superior vena cava, as we said, it is formed from the right common cardinal vein and proximal portion of the right anterior cardinal vein. This is the common cardinal vein, and this is the anterior cardinal vein. This forms the superior vena cava. On the other side, disappear. Congenital anomaly of the great veins. Absence of inferior vena cava due to failure of development. In this case, the blood from the lower half of the body is drained through the azygous vein and superior vena cava. The blood is drained through the azygous vein and the superior vena cava. Complete failure of the inferior vena cava. Or double inferior vena cava. It is caused by persistence of the corresponding veins forming inferior vena cava on the left side, on the right side and the left side. Persistence of these veins and these veins forming double inferior vena cava. Regarding the superior vena cava, double superior vena cava, it is caused by failure development of the anastomosis here. Failure development of anastomosis here. So there is double superior vena cava. Left superior vena cava, it is caused by persistence of the left anterior cardinal vein and obliteration of the right. In this case, it drains into the right atrium through the coronary sinus. Then we come to the most important point. here in this lecture, which is the fetal circulation. Fetal circulation. Fetal circulation differs from the circulation of the baby postnatally, or from the adult circulation. Here is the placenta. Oxygenated blood come from the placenta, passing through the umbilical vein, which is the left umbilical vein, as we said before. Passing through the left umbilical vein, then pass through the ductus venosus. This is a duct connecting the umbilical vein with the inferior vena cava. Then passes to the inferior vena cava. Then passes in its direction upward through the foramen ovale, from the right atrium to the left atrium, through the foramen ovale, which should be persist patent during the intrauterine fetal life, as we see before. Then the blood descend from the left atrium through the mitral valve to the left ventricle, then ascend upward through the aorta, passing mainly through the 3 great blood vessels originating from the aorta, which are named left subclavian, left common carotid, and brachiocephalic vein. This is the circulation of the oxygenated blood from the placenta, umbilical vein, ductus venosus, inferior vena cava, right atrium, foramen ovale, left atrium, left ventricle, as ascending aorta, arch of the aorta, 3 big vessels originating from the aorta, mainly to the upper half. Then non-oxygenated or deoxygenated blood return mainly to the superior vena cava. So the inferior vena cava carry oxygenated, while the superior vena cava carry non-oxygenated or deoxygenated. Deoxygenated mainly come from the upper half, as the oxygenated blood mainly reaches the upper half. This is the cause for more development of the upper half of the body, including the head and the brain of the body, more than the rest of the body. So non-oxygenated return to the superior vena cava, to the right atrium, descend downward to the right ventricle, then ascend to the pulmonary trunk. Then from the pulmonary trunk, as we know, the 2 lungs are non-functioning during the intrauterine fetal life. So this duct come to take the blood from the pulmonary trunk to the descending aorta. So as we see, the descending aorta supplying the lower half of the body carries mixed blood, oxygenated and non-oxygenated. This is another cause for slow development of the lower half of the body, as the descending aorta carries mixed blood. Then the non-oxygenated blood passes, as we see, through the descending aorta to the iliac aorta, to the 2 umbilical arteries, to return to the placenta. This is the circulation of the fetus, or the fetal circulation during the intrauterine fetal life. Small point to be noted: the umbilical vein and the pulmonary vein are vessels carrying the reverse of the usual blood. So the artery, you know that the artery carry oxygenated blood and the vein carry non-oxygenated blood. But the umbilical vein and the pulmonary vein are exception. They carry the reverse blood. The umbilical vein carry oxygenated, not non-oxygenated, and the artery carry non-oxygenated, not oxygenated, umbilical artery. And also pulmonary blood vessels later on after birth. This is the circulation, fetal circulation. Then we talk about the circulatory changes after birth. After birth, after with the first cry of the baby, the lung begin to function. The lung begin to function. So the establishment of the pulmonary circulation occur. Establishment of pulmonary circulation occur. This results in the left umbilical vein is obliterated to form what is called ligamentum teres, ligamentum teres of the liver. The two umbilical arteries are obliterated to form later on the two lateral umbilical ligament. Some authors name this ligament as medial umbilical ligament, but the correct is the lateral. Anyway, medial or lateral, no problem. You must mention that the two umbilical arteries are obliterated to form two umbilical ligaments, mostly named lateral umbilical ligament. The ductus venosus is obliterated to form ligamentum venosum of the liver. The ductus arteriosus is obliterated to form the ligamentum arteriosum connecting the pulmonary trunk and the aorta. Lastly, the foramen ovale is closed. So, as we said before, so opposition of the septum secundum against the septum primum. The lower edge of the septum secundum forms the annulus ovalis, bounding the fossa ovalis that is formed by the upper part of the septum primum. These anatomical features are seen from the right side of the atrium, from the right atrium. These anatomical changes are seen in the interatrial septum from the right side. Thank you. Thanks.